And next, we need to talk about the aspect of the data reduction. When we work with the machine learning models, we deal with the huge data sets, right? But from the data set what you got collected, you should be able to retain essential details. Since we just need to reduce data to make our model perform better, there is an essence of data reduction in which we're just going to reduce the details. Here there are a lot of aspects, rather a lot of factors will be acting upon the performance of the model. The first aspect is the size. Let us say I have 2 GB of the data set. If the 2 GB total data set is relevant to the model, I have no other option than using the complete data set. But here, in this 2 GB, the total data set in a total table, let us understand, I do not want each and every detail. For our model, only a few details are necessary. A few columns are necessary to train our model when you collect a data set. So in this point, since the machine learning model doesn't require the complete data set, it does require only a filtered data set, we should be able to focus on the data reduction. Because analyze to provide the insights, to divide this into training and testing and testing data sets. Since the total data set is irrelevant, what we need to do is we need to reduce the data in terms of size and the dimensions. Let us understand how the data set will reduce. Okay, so of course the essential process to optimizing data handling, analysis and modeling by the decreasing the amount of data while we retaining its significance. From the data set we need to retain the significant details. The other details should completely be omitted. There are several ways to reduce. The first one, there are several steps in reducing. The first one is dimensionality reduction. We are going to understand aggregation, sampling and data compression, the feature selection. I just am going to manifest this entire topic by a live example, by a real world example. Now let me manifest this entire topic with a real world example. That is, let us take Flipkart. What is Flipkart? Flipkart is an online retail store. Now Flipkart does want to develop a machine learning model in which it just want to segmentize the customers. For it, it just collected a data set. But unfortunately, the data set is huge. The data set has a huge number of columns, more number of columns, with more details. Now, the Flipkart, in order to train and test a model and deploy it, it needs to reduce the size of the data set. Because this model, this data set is very large with thousands of features and millions of records processing with such large C. The first thing is resources. Whenever you collect a data set, the data set, first of all, if you want to download it, this doesn't get downloaded even on a system, because most of the data set, if you analyze, will actually be in GBs. Okay, 20 GB, 30 GB. These are resource intensive, right? Will you be able to download a data set which is around 20 GB to 30 GB? It is not possible because our resources are very limited. The data sets which are huge in nature will be resource intensive. So we should be able to reduce the size of the data set by preserving the essential details, essential columns only. So how do we be able to do it? That's the presence of irrelevant or redundant features. There is a redundant feature. There are several columns which are correlated with each other. Let us say there are 100 columns. All these 100 columns, out of these 100 columns, 90 columns are correlating. 90 columns are more or less one are the same. Only 10 columns are distinct and different. So I just do want to compress this data set only to a limited columns in which we'll be able to extract the relevant features. We should be able to preserve the relevant features. Okay. Now, if you have redundant values, if you have redundant features within the data set, that leads to overfitting. What is overfitting? Overfitting is a scenario that makes you feel that your model is performing too good. For an instance, the total data will be divided into training data and a testing data. The model will be able to perform well with the training data, but it is going to perform very bad in the testing data, which is called overfitting. Okay, there is another scenario which is called underfitting. Underfitting is not the biggest problem because underfitting tells you that model is not ready. Underfitting tells you that the model is yielding worst performances, so that we will be able to change the how the model works. But the overfitting gives you an illusion such that the model is performing very good, because the total data will be divided into training and testing. Training, it's good. total 80% of the data will be divided into training, 20%, this is the actual division. This is rather, the example division. 80% of the data will be divided into training and testing. Training data 80%. For 80% this data, the 80% of this data, when it is fed to the machine learning, that model performs well. The machine learning model, it performs well. Remaining 20% of the data model will not be able to perform accurately. So that means overfitting. What is underfitting? Underfitting is very simple. Even for the training data, it doesn't perform well. So what does it mean? We need to change our strategies. We need to, update our model in such a way that it performs good. Overfitting is the biggest problem because the problem is with our data set. The data set is huge. We are not able to crop the data set. We are not able to compress the data set in such a way that it is enough and sufficient for our machine learning model. So what we do is, in order to reduce this overfitting, we need to go for the dimensionality reduction. Let us understand how this is going to work. Let me explain you by using this same, some features. Dimensionality reduction with PCA. PCA is one of the component or a tool or a feature by using which we'll be able to reduce dimensions. I can't technically say it's a feature. It's a tool or a component. What is PCA? PCA is principal component analysis. What is this component analysis? Principal component analysis. Out of 100 features, preserve only the required features, which are called principal components. What are the principal? The data set has 200 features, many of which highly correlated or contribute little to the overall variance. Out of 200, there are 180 or 190 features which are correlating with each other, more or less one and the same. They are talking about the same feature, but remaining 20% or 15% are distinct. So here we should be able to extract only those distinct features by collecting only essential from the remaining 180. So PCA applied to reduce these features to only 10 principal components that covers 95% of the data set. Okay, by PCA, what is PCA? Principal component analysis, we will be able to extract only the important features, 10% of the important features, which covers the total, which tells you about, which talks about 95% of the total data set variance. Variance meaning the difference in features, okay. This reduction significantly lowers the computational cost. Obviously, computational cost will get reduced, time complexity will get reduced, the way the model performs will get better as you reduce. Okay, and since it is going to maintain the dataset's essential information. Feature selection. Yeah, before the dimensionality reduction, we need to also be able to select the features, right? Out of 200 features, which are relevant, which are irrelevant. How do you know? For that, there has to be a pre-work done before you apply the principal component analysis to the data set. That is called feature selection. In feature selection, we should be able to extract only those features, such as, for instance, purchase frequency, average transaction value, customer's lifetime value. Only these details, relevant details, which actually are going to fit exactly to the model, will be extracted. So before this PCA is applied, we need to go for the feature selection. Before applying the PCA, feature selection technique is used to identify the most important features. We are going to identify the most important feature by using something called a feature selection. After feature selection, you can apply dimensionality reduction with PCA. Next thing is sampling. Right after the data set has actually been reduced, to train our model, there is still ambiguity because we cropped our total data set, right? The data set actually has been cropped. How do we know? Can we use this cropped data set, reduced data set directly? Will our model be able to perform better? To answer this, because there is always an ambiguity before you feeding the data set to the machine learning model, right? So what we do is we just go for sampling. What is sampling? Out of this data set, we just take 10%. We just take 10%. We'll make sure this 10% of the data set covers every aspect of the data set, which is called sampling. And to quickly build an initial model, a stratified random sample of 10% of the data set is taken to ensure all the customer types are proportionally represented, which is called sampling. It's just random sampling. What is random sampling? Out of the total data set, after the cropping, we'll take 10%, from which the total customers will be covered. Total features have actually been covered. In our Flipkart data set, the data set belongs to the customers, right? This allows the company to validate the segmentation strategy. We'll be able to properly segment. right? That the model has to segmentize the customers. The model that is going to be built is going to segmentize the customers, for which sampling is important right after you crop the data set. Aggregation. One more thing is an aggregation. See, data set will be huge, right? In order to reduce the data set, what we actually can do? Let us say there is a record. Daily purchase record. Some customers daily purchase. Some customer doesn't purchase daily. Rather than going for a daily purchase record which is going to add a huge volume to the data set, we can aggregate a total daily data set, the daily purchase column to a monthly purchase column, right? So this will reduce the dimension. This will also reduce the size, because size also takes an important parameter, right? Is an important key parameter or a factor which affects the model performance, right? So we can reduce this size by effectively aggregating daily purchases to monthly purchases. Daily purchases will be 30. Per month we'll have 30 columns. For a monthly purchase, it will be only one column. Doesn't miss any feature, doesn't miss any detail of the daily purchase. All the daily purchases will be aggregated here. That is what? Aggregation here. Another technique is DR with singular value decomposition, SVD. Not to reduce, but understand, this is very helpful for recommendation systems such as YouTube. What YouTube does? YouTube is going to recommend you the right videos at the right time. Morning you may require something, afternoon you may require something, evening it may suggest something else based on your needs, because there are patterns that will be observed from your past history. The total past history will get collected, from which it will be able to identify the patterns, and then you will be suggested with a corresponding videos or corresponding play. Now, there is something called singular value decomposition. What is singular value decomposition? It takes your total data in a matrix or a table. This total matrix will be divided into 3 sub-matrix. For better analyzation, rather than analyzing a single matrix, it is going to divide this into 3 matrices without affecting the structure, and from which it will be able to extract the relevant features, from which it will be able to suggest you the right videos at the right time. This is called SVD, the matrix factorization technique that decomposes a matrix into 3 other matrices to capture the most relevant and important features without affecting the structure. Okay, and next thing is the distributed stochastic neighbor embedding, which otherwise can also be called as SNE. This SNE is only for data visualization. By using this technique, we'll reduce the data set. See, total data set you don't need to visualize. So before you apply the data set before you use this data set for the machine learning model, what you need to do is, first of all, you should be able to visualize. Is it possible to visualize the total data set? No, we need to reduce the data set, right? After reducing the data set, we'll be able to visualize, right? Then we'll be able to use this data set for the model. So for the visualization, there is one technique which is called distributed stochastic neighbor embedding, which can also be called as a TSNE. A non-linear technique ideal for visualizing high dimension data in 2D and 3D. By using 2D and 3D methods, we'll be able to visualize the data in distributed stochastic neighbor and embedding, TSNE. Okay.